Okay, so this is the fourth and final lesson on partial fractions, and basically we're going on to those part B. So part A is always do the partial fraction, and then part B is using that bit of information that you've done in part A, solve this problem. And today we're going to look at two things that we can do in part B. There are another two things that we can do in part B, which is integrate and differentiate, but we won't do those until we've done the integration and differentiation chapters. So the first one is using one result to quickly find another result. So this is a very simple example to begin with. They're usually like the example we're going to do in a minute. But the first bit, simplify 5x plus 1 over x squared minus 1. And it doesn't really explain what it means by that, but it means write it as a partial fraction. So what we've got to do is, for our part A, we've got to say 5x plus 1 over. Now, I need to factorise this denominator. And as we can see, it's a difference of two squares. So that just becomes an x plus 1 and an x minus 1. And so I can write that as a over x plus 1 plus b over x minus 1, splitting it into its two partial fractions. And so from that point we can quickly say 5x plus 1 is equal to a times x minus 1 plus b times x plus 1. So quite a simple one actually from the ones that we've been doing quite recently. So we can do this quite quickly. Let x equal 1. We get 6 is equal to, well, the a coefficient disappears, so we get 2b. Therefore, b is equal to 3. Second substitution we're going to use is x is minus 1. So minus 5 plus 1 is minus 4 is equal to, this time the a term is going to survive, the b term is what's going to disappear. So we're going to get minus 2a. So therefore a is 2. So my 5x plus 1 over x plus 1 times x minus 1 is 2 over x plus 1 plus 3 over x minus 1. Okay, so we've done part A. And then part B says, hence or otherwise, express that as partial fractions or as the sum of partial fractions. So part B, I'll change colour. I need to express 5x plus 1 over x squared minus 1. I think it was, oh no, minus I should say. Minus 4 over x minus 1 as a sum of partial fractions. Well, this is where I'm going to use this and substitute it for my 5x plus 1 over x squared minus 1. So then this then becomes 2 over x plus 1 plus 3 over x minus 1 for the substitution of this. Take away 4 over x minus 1. Right. Now, let's have a look at this. Just do a little side note to begin with. So, if I had something like 1/5 plus 2 quarters minus 1 quarter, well, actually, I could just combine those two together because 2 quarters take away 1 quarter would just be 1 quarter. Let's do a bit of a different one. What happens if I had 7/10 plus 2/9 minus 3/9? Well, again, I could combine those two together first, because what's 2/9 take away 3/9 is just going to be minus 1/9. And so the exact same thing is happening here, because these two have got a common denominator. So I'm almost saying 3x minus 1ths minus 4x minus 1ths. And what would that become? Well, if I've got 3 of something and I take away 4 of something, then I'm just left with minus 1 of something. So, because I haven't got enough space, I just need to move this up a little bit. So what's my answer going to be? It's going to be 2 over x plus 1, because I've still got 2x plus 1ths, minus 1 x minus 1ths, because I had 3 of them, but now I'm taking away 4 of them. Okay, So what they tend to look like is a little bit more like this, so a little bit of a harder one, but we'll do it in exactly the same way. So our part A, just what we've been doing previously. So let's have a go. So we've got 4x squared plus 7x minus 6, and I'm just going to go from here. I'm not going to write that line out again. So is going to be A. What do I need to multiply this denominator to make it equal to this? Well, I need an x and an x plus 3. Plus, let's do the second fraction. What do I need to multiply this denominator to match it up? I just need an x plus 3. And then the final one, what do I need to multiply this final denominator by? I need an x squared. Okay, so let's go. First substitution is x equals 0. Minus 6, well, the a term is gone, the c term is gone, and I've just got 3b. Therefore, b is equal to minus 2. Let x equal minus 3 for the next one. And as always, I haven't got my calculator with me. So I've got 4 times 9 is 36, minus 21 minus 6. So 36 minus 27 is 9, is equal to, the a term has gone, the b term has gone, and I've got minus 3 squared, so that's going to be 9c. Therefore, c is equal to 1. And the final one, I'm going to use a nice easy number, let x equal 1. So I've got 4 plus 7 minus 6. So 5 is equal to, right, a, I've got 1 times 4, so I've got 4a for my a term. For the b, I've got 1 plus 4, so again I've just got 4b, plus, with the c term I've got 1 squared, so I've got c. So I've got 5 is equal to 4a plus 4b. Now b is minus 2, so that's going to become minus 8 plus 1. So I've got 5 is equal to 4a minus 7. 12 is 4a. Therefore, a is equal to 3. So there are my 3 terms. So let's have a look. So it's going to be 3 over x. It's going to be minus 2 over x squared plus 1 over x plus 3. And there is my original fraction split into its sum of partial fractions. Okay, so I've done part A. So part B is a little bit more complicated, but what I'm going to do is I'm going to copy this over, okay, to the next page, because I've got my answer to part A. Okay, now then, let's do part B. So B, it says hence or otherwise. So what it wants me to do is it wants me to use part A, because I've got to be honest, part A would probably be worth about 4 marks in the exam. Part B is only going to be worth 2 marks. So if you went through the whole process again using the normal method for working out partial fractions, then you're doing more work than you need to, because it's telling you this is only worth 2 marks. Okay, so what it wants us to do is it wants us to use part A. And what I've got to think about is I've got to write this 4x squared plus 12x plus 9 all over my x squared and x plus 3. And I want to use this. So actually I'm going to write that that's 4x squared plus 7x minus 6. Now, but I had 12 x's, so guess what? I need another 5 x's, because I need 12 x's. I've got 7x from the first one, so I need an extra 5x. And equally, I had minus 6, but I want 9. So I need to add another minus 6, so I need to add another 15, okay, because I'll just get my highlighter. I need to have plus 9, and minus 6 add 15 makes plus 9, okay, and all of this is over my x squared times x plus 3. So again, I get my highlighter. This was my original bit from up here, and I needed an extra 5x and an extra 15 to get my second fraction. So scroll up now. I've got my 4x squared plus 7x minus 6 all over my x squared times x plus 3, and that is the same as, and then I'm going to add my 5x plus 15 over my x squared times x plus 3. And this should always happen. If you get in a question like this should always happen. What you should notice is the fact that 5x plus 15 is the same as 5 times x plus 3, okay, and what you find is that one of the brackets will then cancel. So effectively what I'm left with is 4x squared plus 7x take away 6 over my x squared times x plus 3 plus 5 over x squared. And this is when we then use our partial fraction, because we're then going to use the fact that this has been split into partial fractions in the previous example. Okay, so in the previous part A, we already did this splitting into partial fractions. So I can say that's 3 over x minus 2 over x squared plus 1 over x plus 3. And now I've got this extra 5 over x squared. So just like we did in the previous example, I can add things with the same denominator. So I can think I've got minus 2 over x squared plus 5 over x squared. So what does that give me? Well, I've still got my 3 over x, but if I've got minus 2x squared plus 5x squared, then I'm left with 3 over x squared. And the final bit plus 1 over x plus 3. So what you're doing is you're using your answer from part A and you're thinking, what extra bit have I got? Okay. Right, we'll do one more of them. Okay. Now, this one was quite nice in that they sort of like reminded you that this was an improper fraction by saying express 3x squared minus 2x plus 4 over x minus 3 times x plus 2 in the form a plus. Okay, so it's reminded you that you've got to do that polynomial division first. So let's just do part A. Again, this is recapping what we did last lesson. So effectively what I've got is 3x squared minus 2x plus 4 divided by, and if I expand the little double bracket in the denominator, I've got an x squared minus x minus 6. So going back to our polynomial division. So what have we got? We're dividing by x squared minus x minus 6. Okay. I have a 3x squared, so I must have had a 3, because 3 times x squared makes 3x squared. Multiply down that column, minus 3x and minus 18. But we need to make our diagonals match, so if we remember, this has to match our minus 2x. We've already got our 3x squareds, and this diagonal has to match our plus 4. So what needs to go in the remainder column? Well, I've got minus 3x, but I only want minus 2x, so I need an x there. And I've got a minus 18, but really I need a plus 4. So I need a 22 there. So the first step is I can write that my 3x squared minus 2x plus 4 over the two brackets is 3 plus x plus 22, still to be divided by the x minus 3 and the x plus 2. Okay, and now I've got to do the partial fractions on here. So x plus 22 over x minus 3 times x plus 2 is equal to a over x minus 3 plus b over x plus 2. So I get x plus 22 is a times x plus 2 plus b times x minus 3. So let x equal minus 2. So I'll get 20 is equal to, the a term is going in this case, minus 5b. So b is minus 4. And then I'm going to try let x equal 3. So I'll get 25 is equal to, in this case the b term has disappeared, and I've got 5a. Therefore a is equal to 5. So what is my final answer? I have got 3 plus 5 over x minus 3 minus 4 over x plus 2. Okay, so that was the answer. So again, I'm going to copy that. Copy. And then I'm going to put it over here. So I've got my answer. Paste. So that was the answer to A. So my A was 3, my B was 5, and my C was minus 4. Right, now again, let's do this part B, hence or otherwise. So again, to use the word hence, you're going to use part A. So I want to write my 3x squared plus x minus 5 over my x minus 3 and x plus 5 as my original equation with other bits added or taken away to make it match. Now I need a plus x. I've got minus 2x, so to make that plus x I need to add 3 x's. Okay, because 3x take away 2x makes plus x. Again, I've got to make this minus 5. I've got a plus 4, so what do I need here to make it minus 5? I need to do a take away 9. And again, all of that is over the double bracket, but I'm going to write them separately because I know I'm going to have to cancel, and I know I'm going to use the partial fractions. Okay, so I'm going to substitute this here. So that's going to be 3 plus 5 over x minus 3, minus 4 over x plus 2. And then I know with this other part over here, I know something's going to cancel. And actually, if I look, I can say I can take out a factor of 3 that, and I'd have x minus 3. So guess what? Those two brackets would cancel, and I would be left with plus 3 over x plus 5. So, sorry, where's the x plus 5 come from? Oh my word, I should have made that an x plus 2. Sorry, I'll change that because that doesn't make sense otherwise. Okay, because it was supposed to carry on, it was me writing it out incorrectly. Okay, so that should be over x plus 2. Alright, so again, what can I do now? I can collect these two fractions together. So my 3 stays the same, my 5 over x minus 3 stays the same. Now I've got minus 4 somethings plus 3 somethings, so I'm going to be left with minus 1 of it. Okay, and so part B, what is 3x plus x minus 5 over the two brackets? That would be 3 plus 5 over x minus 3 minus 1 over x plus 2. Okay. Right, I've got 3 for you to have a go at. So I'm just making sure my denominators are the same for this, and they are. So press pause, have a go at the 3, and then I'll show you the answers. Okay, so let's have a look at number 1. So, number 1, first step obviously to factorise the denominator. Work out your partial fractions, and as you see, you can probably get quite quick at these now. So you should have got b is -1 and a is 3. So with your partial fractions, you had x minus 11 over the double brackets is 3 over 2x plus 5 minus 1 over x minus 2. Now we've got to think how we can relate these two equations together, and what we can say is, we can say, well, 5x minus 1 is x minus 11 plus 4x minus 10, because x plus 4x makes the 5x, and minus 11 plus the 10 makes the minus 1. Okay, we can see we can factorize this 4x plus 10 to be 2 brackets 2x plus 5, so that cancels. Use your partial fractions, and you should hopefully have had the same answer as me. Right, now second one, bit more complicated because obviously it's a harder partial fractions to begin with, so this is definitely a lot more typical of what you would find in an exam. First part, again, exactly the same way as normal, so you should have had that fraction equals 2 over 3x minus 2 minus 1 over 3x minus 2 squared plus 5 over 1 minus x. Then we go on to part B. Again, we've got to think about relating this second fraction to the first one, and we can say, look in here, minus 49x minus 5x makes the minus 54x, and 15 add 5 makes the 20. So we've split it into the partial fraction part and the non-bit. Again, we find if we take out a factor of 5 of that numerator, the 1 minus x cancels, and so hopefully you should have had the same answer. And the final one, again, partial fractions, a little bit more complicated, but you should have got the answer 18 over 3x minus 2, 9 over 3x minus 2 squared, and 10 over 2 minus x. Okay. So again, relating that second fraction to the first, or the fraction in part B to the fraction in part A, and we get the 19x by doing 15x add 4x, and we get the minus 22 by doing minus 14 minus 8. Again, factor of 4 comes out. So now this is where it's actually, it can look a bit different, this one. So I will take a minute just to explain. Obviously we took a factor of 4 out here and we had x minus 2. But unfortunately at this moment these two don't exactly match. They look very similar but they don't exactly match. So you've got to remember, look over here, if you take out a factor of minus 1, then you effectively have minus x plus 2, or 2 minus x. So actually, rather than having a factor of plus 4 taken out, we actually took out factor of minus 4 to make the two brackets match. So then it became the partial fractions, or the sum of the partial fractions, take away 4 over 3x minus 2 squared. And if you add 9 of them and you take away 4 of them, you're left with 5 of them. So hopefully you got the right answer there. Okay, the second application is going on to use binomial expansion. Now you'll only be able to do this if you've done Mr. Sutherland's questions from last week, which you should have done. So hopefully you have. So let's have a go. So first part, again, these are usually a bit more straightforward. So 8x over 1 minus 4x squared. Well, the first thing you've got to do is factorise this denominator, difference of 2 squares. So you've got 1 plus 2x and 1 minus 2x. So it's going to be a over 1 plus 2x plus b over 1 minus 2x. Okay, just move that up a bit, otherwise I'm going to run out of space. So I've got 8x equals a times 1 minus 2x plus b times 1 plus 2x. Let x equal a half to get rid of the a term. You're going to get 4 equals 2b. So b is equal to 2. Let x equal minus a half, and that'll get rid of the b term. So you're going to get minus 4 equals, because 2 minus 2 lots of minus a half is going to be 2a. So a is minus 2. So our partial fractions are going to split into minus 2 over 1 plus 2x plus 2 over 1 minus 2x. So there's part A. Okay, so we've split our fraction into the sum of two partial fractions. Right, part B. Find the first two terms of the binomial expansion of 1 over 1 plus 2x. So, part B, 1 over 1 plus 2x. Well, I always write this as 1 plus 2x to the minus 1 because the 1 plus 2x is in the denominator. So if we think about that, that means it's to the power of minus 1. And going to our binomial expansion, first term is always 1 plus n, which is minus 1, times x. But our x in this case is the 2x. So I'll just annotate this. So remember that's the n and that is the x. Okay. The second term is n times n minus 1 times x squared, which in this case is our 2x squared all over 2 factorial. And then the third term is the n minus 1, n minus 2 times the x, which in this case is 2x cubed over 3 factorial. Now, quite nice. 1 minus 1 times 2x is minus 2x. Right, you've got a negative times a negative, so that's going to make a positive. You've got a 1 times 2. Well, that's going to cancel with the 2 factorial because that's 1 times 2. So really, all you're left with in this term is a 2x all squared, so that's going to be plus 4x squared. Okay. And then the third term, you've got a negative times a negative times a negative, so you're going to get a negative. Again, the 1 times 2 times 3 is going to cancel with the 3 factorial. So all you're left with is the 2x all cubed, so that's going to be 8x cubed. Okay, so let's just get a couple of these things over to the next page. So we've done part A and we've done part B. So hopefully I've just copied them over for us. There was the answer to part A, there was the answer to part B. Now again, using part B for C, find the first 4 terms of 1 minus 2x. Well, 1 over 1 minus 2x is just 1 minus 2x to the minus 1. And again, you probably not realise this, but I'll do it properly and then maybe you'll spot something. So in future you should be able to just recognise these. So we'll do this properly. So I've got 1 plus, again the n is minus 1. Now this time my x term is minus 2x. So I've got minus 2x. So I've got n times x. Second term, n times n minus 1 times my x term, which is my minus 2x squared over 2 factorial. And the third term, I'm going to run out of space, minus 1, minus 2, n minus 1, n minus 2, n minus 3 is minus 3 times my x term, which I'm going to have right above because I'm running out of space. And this time it's cubed divided by 3 factorial. And what you notice is you start with your 1 always. Now, this time we've got a negative times a negative, so it becomes plus 2x. Now, on the next term, we've got a negative times a negative squared, which is going to be, again, a positive. The 2 factorial cancels, so you get 4x squared. And on the final term, we've got a negative times a negative times a negative cubed. Now, effectively, you've got 6 negatives there. So that, again, becomes a positive. And so you end up with 8x cubed plus. And you always find this relationship, okay? So if you've got a positive and a negative, the even terms always stay the same, but the odd terms always change sign. And it's because you've got this odd number of negative terms. Okay, so that just always happens. All right, you don't have to use the hence, you can just work it out anyway. Right, so now then, part B. Hence find the first four terms of the binomial expansion of that. Now, I know this is exactly the same as this. So I know 8x over 1 minus 4x squared is exactly the same as minus 2 over 1 plus 2x plus 2 over 1 minus 2x. So effectively, part D is just saying find the binomial expansion of minus 2 over 1 plus 2x plus 2 over 1 minus 2x. Right, let's think about what each of these is. So, because I'm going to run out of space here. So, this here is the same as minus 2 times 1 over 1 plus 2x. Okay? Because thinking about fractions, multiply the denominators, multiply the numerators. And so actually, that, I always tend to write this as minus 2 times 1 plus 2x to the minus 1. But I've worked out what 1 plus 2x to the minus 1 is. So actually, what I've got is minus 2 times, well, what was that? It was this first expansion here. It is 1 minus 2x plus 4x squared minus 8x cubed. So that is this purple bit here. So this is the first fraction. It's minus 2 lots of the expansion for 1 over 1 plus 2x. I'll use a different colour now. So for this fraction, I've got, again, if we think about this, that's 2 times 1 over 1 minus 2x. But again, I tend to write that as 2 times 1 minus 2x to the minus 1. So I'm going to add 2 times, what was that expansion? It was 1 plus 2x plus 4x squared plus 8x cubed. So what do I have all together? I've got expanding this purple expansion, minus 2 plus 4x minus 8x squared plus 16x cubed, because I've got minus 2 times each of the terms. If I expand the second bracket, I've got plus 2 plus 4x plus 8x squared plus 16x cubed. And adding them together, well, the minus 2 add 2 cancels. 4x add 4x makes 8x. Minus 8x squared and 8x squared cancels. And 16x cubed plus 16x cubed makes 32x cubed. Okay, quite a lot to that, and I might have gone a little bit quick, but have another little look and have a go at these two. Okay, again, press pause, and when you press play again, I will show you the solutions. Okay, so first part, quite a simple partial fraction question. So you should have got minus 4 over 1 minus x and 3 over 1 plus 3x. Part B was saying do the binomial expansion of each of those two fractions, the 1 over 1 minus x. You should have got 1 plus x squared plus x cubed. Doing the binomial expansion of 1 over 1 plus 3x. You should have got 1 minus 3x plus 9x squared minus 27x cubed. And then this is the slightly more complicated bit. So we've got minus 4 lots of this expansion of 1 over 1 minus x. So that comes here, minus 4 lots of this expansion. And then we've got 3 lots of your second expansion, you 1 over 1 plus 3x, so you've got 3 lots of 1 minus 3x plus 9x squared minus 27x cubed. Expand the brackets, collect the terms, and hopefully you had the same answer as me. And then for the second one, again, not too difficult, the partial fraction. The binomial expansion, again, not too difficult. Okay, so you should have got that for the first binomial expansion. Second binomial expansion we'd already done, so you could have probably just copied that from the one you'd done previously. Okay, and then the part C, combining it together. So again, I've got 5 lots of that first expansion. So 5 lots of that first expansion for the 1 over 1 plus 4x. And we've got 2 lots of that second expansion. So 2 lots of the second expansion. And the only thing to note here is you've got a takeaway. So be careful when you do your expansion. You know, most of us do minus 2 lots of the bracket. And then hopefully you add the same answer. Okay, so like I said at the start, there's only 2 other applications really after a part A. You go on to then either differentiate or integrate, but we need to have done the differentiation and the integration chapters first, so we will come back to these later. Okay, goodbye.